I apologize if they seem a little more intense than normal, but I want to stay on schedule. Okay. So, solving higher order equations, right? So now we're masters at solving quadratic equations, right? No problems at all. Or at least we have a good idea about what we're supposed to do, and we'll need to practice. And we know where we need to practice and stuff like that too. Solving higher order equations. So what do I mean by higher order? I mean like higher degree, right? So now we're talking polynomials, not just quadratics. Some of these skills do apply to quadratics, but they also talk about cubics, quartics, I guess quintics, and then, you know, however much higher you want to go. So the first thing, just like we started with quadratics yesterday, today also, the first thing you want to look for is a GCF, to see if you can factor out that GCF. Okay, and of course, the big thing we're going to be using here also is that zero product property. So we're looking to have it be equal to 0 and then solve from there. So just as an example here, okay, again, let's just solve the equation. That'll be all of our directions today, just to solve the equation. Okay, so 3x to the 4th plus 10x to the 3rd plus 8x squared equals 0. Okay. Now again, I'm kind of making it a little bit easier right now because, well, we're in the GCF section of the notes, and I'm asking us to solve this problem. So, okay, it's unlike what you would, experience when you're in the wild, right, so to speak. You come across this problem, it wouldn't tell you what strategy to use. So you would need to, kind of have in your mind the different tools that we're going to use to factor or to solve an equation. To solve these polynomial equations. Okay. So one of the tools is GCF. So what is our GCF here that we can factor out? Brian? X squared, that's right. So we factor out an x squared, and then what remains, Brian, when we factor that x squared out? 3x squared plus 10x plus 8. Okay, great. So that helps, right? So now we have what was, x to the 4th. We now have x squared times, and then we have a quadratic here in the parentheses. So that's really helpful because we can factor that using the strategies we just learned, right? I'm going to factor this using the guess and check method. Well, just because I can, it's not going to be too bad. So I know I need to do, in this case, we need a 3x times an x to make 3x squared. Right, and I need two numbers in here that multiply to make 8, but then when combined with the 3x and the x, they're going to make a 10x. So let's see here. What are two numbers that multiply to make 8? Caleb. Oh, you're doing the magic x thing. Okay, so, all right, well, we can do it that way. Let's see here. Let's see. Let me go with that better then. So 3 times 8 will be 24. Add the middle term, there'll be 10. Okay, so what are your two numbers here that go on the magic x? 6 and 4? Sounds good. Okay. If you're doing Andrew's method, it's the same idea here. You would get the 6 and the 4. So if the middle term here, the 10, you break it up into 6x and 4x, and then factor by grouping. Okay, at that point. So yeah, then we have to divide both those by 3. And so we're going to get 2 here, and then 4 by 3. Okay, so it's going to be what? X plus 2. And then 3x plus 4, like that, is what it factors to be. Okay, and that is right. That's what it does factor to be there. All right. And so then, Brian, how do we finish solving here? What do we do? Yeah, so we set each one of these things equal to 0. So we get x equals 0, we get x equals negative 4/3, and we get x equals negative 2. And so those are our three solutions. And of course, okay, Andrew, question?
I just split apart the 10x cubed.
So this is 10x? Oh, from the middle, from the very first thing, gotcha.
Yeah, so I ended up with 3x cubed plus 4x squared times x plus 2. And
all right, so hang on.
So is it coincidental that the 4 and 4x squared would actually be part of the solution if I done it your way.
All right, so let me go to what you were doing here real quick so we can kind of get some context. So you said you broke up the middle term
Yeah.
at the very start. So you kind of started to factor this thing almost like it was a quadratic. But you do 3 times the 8, the 24, and then you see what two numbers multiply to make 24, but add to make 10. You split up the middle term there, so that 10 became the 6 and the 4. Okay, and then you factor by grouping these things together.
Yeah.
Ah, okay. So so you factor out a 3x to the third here. Okay, and then x plus 2. Okay, sorry. And then let's see, you factor out a 4x squared here.
Yep.
Okay, and we're left with what? X plus 2. And so yeah, we get x plus 2 times 3x cubed plus 4x squared equals 0. And then yes, you can then set each one of these factors equal to 0. And then this one would factor a little bit more because you factor out the GCF there. Yeah, that works. Definitely.
Okay, so it's not coincidental then that it was negative 4/3 and I had a 4 and a 3 as my as well as multiplying the
Like,
y.
like this right here, you're saying?
Yeah.
The fact there's a 4 and a 3 here, we end up with a negative 4/3?
That's
Right.
not
It's
coincidental.
not, no, it's not coincidental. So again, the x plus 2, there's no more GCF we can factor out of that, but we can factor the GCF of x squared out of here,
Yeah.
and then we're left with 3x plus 4. And so there's the negative 4/3 you're going to get.
And the x squared would also give you...
Would also give you 0. Mm-hmm. Yeah, so it doesn't matter the order. If they multiply to make 0, you just set each one of those things equal to 0 and solve from there. Okay? All right. That's GCF. Add that to your toolbox of strategies to solve a polynomial equation, higher degree. All right. Strategy number 2, grouping. We've already kind of seen this. Okay, we've already kind of seen this. Okay, one thing about grouping is you really only want to use grouping when you have an even number of terms. Because otherwise your groups won't be even. Alright, so in other words, this first question that we did, not a good candidate for grouping because there's an odd, right, 1, 2, 3 terms here. But for grouping, we really want an even number of terms. So for example, and again, in the wild, on your own, when Mr. Lemeyer's not over, over your shoulder being like, all right, now we should use grouping. You will just be thrown a problem like this, and you'll need to decipher what strategy to use. So for example, GCF would not be a useful strategy here because there isn't one, right? So that's not helpful. So now we'll try grouping because we see we have an even number of terms. And you can kind of see that if we do group these two pairs of numbers together, now suddenly in each of those groups we do have GCFs we can factor out. Right? So from this first group, what can we factor out? Anyway, x squared, right. So we're left with x plus 5 behind that. And then from the second group, what can we factor out? A 4, yeah. So, plus 4, and again, what's left behind? X plus 5. So now we're like really sure we're on the right track because we have an x plus 5 and an x plus 5. Okay? At this point, we went from a thing that had 4 terms to really 2 terms. It's this product plus this product right here. So it's really like 2 things being multiplied together. This product plus this product. But each one of these terms has what in common? X plus 5, which means those can be factored out. That's a GCF that we can factor out in x plus 5. Okay? And if we remove the x plus 5 from this term, we're left with just the x squared. And if we remove the x plus 5 from this, we're left with just the 4. And so there, we've been able to factor it. And the whole purpose of this is to get a product of things to equal 0, so that we can use that 0 product property and say, well, if 2 things multiply to make 0, that means one of those 2 things has to be 0. So either x plus 5 is 0, or x squared plus 4 equals 0. So x equals negative 5, or x squared equals negative 4. So, the imaginary solution is going to stop right there. So this only has one real solution. Okay, only one real solution. All right, so we'll do one more together here, and then I'll have you guys try one on your own. All right, so one more of these grouping ones. So I'll just scoot this one over. Questions? Any questions so far? Any questions so far? Okay. Again, sorry guys. I know this is a little more of an intense day than we maybe wanted it to be for a Friday, but we have to stay on track here, on time. So, thank you for your patience. All right, next. There's this one. Okay. Right now there should be alarms going off in your head about the way this problem is written. What do we need to do? What's off about this problem here? What do we need to do? Yeah, Caleb. Not equal to 0, right. Okay, good. Your alarms are working accurately. So we're going to make it equal 0, right? Okay. We look at this thing, and we think about the tools that we have, right? GCF. Can we factor out a GCF here? Yes, we can. Ooh, let's do that then, all right? Now, if you went straight into factoring by grouping with this problem, that could still work. You don't have to factor out the GCF first, but I just like to factor out the GCF first because it can make numbers a little bit nicer. So I'm going to take out, what is our GCF here? An X. So that helps to lower some powers here a little bit. Okay. All right. And now, when I look at this thing in here, I'm like, all right, there's no more GCF, but I do have an even number of terms, so maybe I can factor by grouping. So I'm going to group together the first two terms, and now this is going to be a ridiculous number of parentheses you see in here. Okay, so we have to be very careful to keep ourselves straight there. So when I group together these first two terms, what factors out of those first two terms? An x squared, and I'm left behind with a 2x plus 1. And then what can I factor out from these second two terms? Very good, a negative 5, yes. Okay, taking a negative 5 out of a negative 10x leaves me behind with a positive 2x, and then taking a negative 5 out of negative 5 leaves me with a positive 1. So far so good. Questions on how we got it to here? All good so far? Okay, and so then, what do you know? We got that 2x plus 1 and the 2x plus 1 in common here. So we can factor those out and be left with x squared minus 5 equals 0. Okay. So 2x plus 1 equals 0, x squared minus 5 equals 0, and so we get x equals negative 1/2. And, we have to add the 5 over here and then square root both sides. X equals plus or minus the square root of 5. Do I need to get rid of these root 5s here? No, they're okay. They're irrational, but they're still real, so we keep them. What was the question? Yes. Right, we also have to set x equal to 0. Don't forget about this little x out front here, okay? That's also a solution. Okay? And it is very easy to forget about that x sometimes, so please be careful. Okay? I do make mistakes. That one I actually did on purpose. If you believe me or not, well, I guess that's up to you, right? But the x left out in the front there, we oftentimes will forget it. Because sometimes it's just a number out front, and we do forget the number because it's just a number, then it never equals 0. When it's x, that is a solution. So there we have 4 solutions to this equation. All right. Now, alternative to this, right, should you have your graphing calculator with you on any of these problems, these are like super easy at that point. Because all you need to do is graph the left-hand side of the equation, graph the right-hand side of the equation, and then see where those two things intersect at what x values. Okay? So in other words, if you were to go to your graphing calculator, graph this in y1, graph 5x in y2, and then find the points of intersection, you would find 4 points of intersection with x coordinates 0, negative 1/2, and then plus root 5 and then negative root 5. Okay, and that's an easy way. So really, you can solve any equation you ever need to, should you have a graphing calculator, without having to do any work. So. Questions on any of that? Alright, and here's one for y'all to try. Alright, here's one for you. Alright, so you guys try this one here. 3x cubed minus 6x squared plus 2x minus 4 equals 0. Sorry, there it is. Okay. So go ahead and give that one a try. Again, solve for all real solutions, please. Solve for all real solutions. Okay, I think that should be right here, hopefully.
Right, so then we can throw that one out.
How'd you get your glass bill? That's like, oh, that's what it is. Yeah. Everything you did was back.
No, you go to 0, so set equal to 0, right? Yeah, you'll hit 0. Yeah, so each equals 0, don't forget.
I think I should do that. Your little chest.
Oh, okay, I was gonna say. So yes, remember that should be a 3x squared because, yeah, so I see what you're saying. The x though, be careful, you only factor the x from this, not from both. When you flip this extra stuff, when you do the extra, you put all of this stuff, not just here. So it should just be x 3x, as one thing in front of the x minus 2, which then makes 3x squared. So that's the square then, you can just, that will be careful you solve that. Okay, good, so right, we can throw that one out, it's not real, but you just put it to it. Alright, folks.
So there's our solution, 2. Just 2. Alright. Questions on any of that? I got one more strategy I gotta throw your way. Last one though. Okay. So no questions on this last one here, we're all good. Again, you had your two factors end up being x minus 2 and 3x squared plus 2. This will be imaginary when you set equal to 0 and solve, so that's why we just stopped. But the x equals 2 is a solution. Remember again, you can graph the left-hand side, graph the right-hand side, find the point of intersection, the x coordinates for the point of intersection, that will be, solution. Alternatively, you can also take your answer, right, and plug it back in. I know no one ever does that because we just assume we never make a mistake. But should you ever want to check to make yourself, check to see, you can always take your answer, plug it back in, and see if you do in fact get 0. That's nice on like multiple choice, right, where if you don't want to have to like solve it, you can just like go through each multiple choice question and guess and check each answer back in to see if you do in fact get 0 there, right? That's an absolutely valid solution for a multiple choice question. All right, last little strategy here I want to show you, and it's called substitution. Again, not very fancy. And again, we're just gonna show it by example. So again, if you come across, this problem in the wild, and you're unsure about what to do, right? The first thing you look to do, GCF. There's no GCF. Actually, the very first thing we should do here is what? So subtract 65, make sure it's equal to 0. Right, so we'll fix that. We'll fix that here right quick. Yeah, it's 115. Alright. Okay, so we look at this thing and I'm like, well, it's not a quadratic. So, oops, I forgot the x squared. There you go. It's not a quadratic. Alright, let's see, there's no GCF to factor out here. We can't really factor by grouping because there's an odd number of terms. I mean, yeah, we could group the first two together and factor out an x squared, but that's not going to really be helpful because we'll have that minus 100 at the end. So, what do we do? Right? Well, if you look at this problem, the way it's not a quadratic, but it's written very similarly to how quadratics are written. In fact, if I just rewrite this ever so slightly, we have x to the fourth, right, is x squared, and then minus 21x squared, so it's minus 21x squared, and then minus 100 equals 0. Okay. Or to make it maybe even more kind of obvious, we have something squared minus 21 times that same something minus 100 equals 0, right? The something here is the x squared. So we have something squared, the x squared being squared, minus 21 times that something minus 100 equals 0. Okay? And so what we can kind of do here to help ourselves out, we can actually factor this thing like it's a quadratic. We just have to do a slight substitution here. We're going to just use like a placeholder here. Like I like to use u. So we'll say u, let's let u equal x squared. Okay. So wherever I had an x squared, like here is x squared squared, I'm going to make it u squared then, right? Instead of x squared, I'll just put a u, so it's u squared. Right? X squared squared becomes u squared. Minus 21x squared becomes minus 21u. Minus 100 equals 0. And now we'll solve this problem, which is just a quadratic now at this point. So, what are two numbers that multiply to make negative 100, but add to make negative 21? (25) and 4. So, minus 25 and plus 4. Minus 25 and plus 4. And using the zero product property, u minus 25 equals 0, u plus 4 equals 0, and so we get u is 25 and u is negative 4. Okay. So we have solutions, but did we want to solve for u? No, we want to solve for x. But what is u the same as? X squared. So we'll just re-substitute back in for x. X squared therefore is 25. X squared therefore is negative 4. And so we get that, when we square root both sides here, x is then plus or minus 5. And then square root both sides here, it's imaginary, so we're done. And so those are our two solutions. X equals plus or minus 5. X equals plus or minus 5. It's not really necessary here to use this substitution. If you're comfortable factoring from this step right here with the x to the fourth minus 21 x squared minus 100, if you're comfortable with factoring that to just be x squared minus 25 times x squared plus 4, feel free to do it that way. Okay. I just feel like maybe it's sometimes helpful to change that variable to make it look, more palatable. Okay, bless you. All right, we'll do one more here, and then we'll be done. Last one. No more strategies, just one more example, just to make sure we're okay with all this stuff. All right, I'm going to try and squeeze it over here on the other side. All right. So last one here. We're almost there, folks. You can taste the end. Sorry, it's supposed to be cubed. Okay, so 3x to the fifth minus 5x cubed minus 12x equals 0. So 3x to the fifth minus 5x cubed minus 12x equals 0. All right, so first step here. How can we start tackling this? What can we do for our first step? Factor out the x. Very good. Yes, there is a GCF here, so always try and factor that GCF out first. Okay. And now if we look at this thing, we can't factor by grouping because there's an odd number of terms there, so it won't really work out, right? There's no more GCF to factor out. Okay, so we have to try and use substitution here maybe, see if that can work, because it kind of does look like a quadratic again, right? And in fact, if we let u equal x squared again, then we'll end up with 3u squared minus 5u minus 12 equals 0. Ooh, and I'm mixing up my variables here. That's probably not a very good idea, but maybe I can fix it this way. I'll let x equal to 0 already, put that as a solution, and I'll break that up and make it this way. There we go. That's better. So we already have one solution. X is 0, right? We can go ahead and just set x equal to 0 there. And we'll just break up and use the 3u squared minus 5u minus 12 there as well. And so now we're going to factor. All right, let's see here. Again, you can use the magic x if you need to for however you factor, or the product sum thing where you split up that middle term, or you can just guess and check too. So let's see here. So it looks like it's going to be plus 4 and minus 3, I think. 3u plus 4 minus makes negative 12 plus 4 minus 9. Yep, okay, equals 0. So again, we'll set each factor equal to 0. Ooh, u minus 3 equals 0. And so you get u equals negative 4/3, which means that x squared equals negative 4/3. So you square root imaginary. U equals 3, and so x squared equals 3. So you square root, and you get x equals plus or minus the square root of 3. And so 3 solutions there. 0, and then the plus or minus the root 3. Okay. That's that. Questions on any of that? All right. Thank you, folks, for, again, following along so well.